If you've been following this series so far, you've learned the core concepts of Redis AI and have used it from the command line. But, you might ask, how can I use it in my applications? That's the topic for today. We're going to do some image classification with Redis AI, Node.js, and IO Redis. Let's get started. Today, I'm going to teach by doing and build some software. I'm going to build a command line tool that takes paths to images as arguments. It'll respond with what it thinks each image contains, be it axolotls or a zucchini. We'll use a pre-trained model for this, MobileNet to be precise, and of course Redis AI. I'm going to cover the code that loads the model, converts the images into a tensor that our model can understand, performs an inference with that tensor, and then processes the results. We'll look at some of the required libraries first. We're using FS to load files from the file system, IO Redis to talk with Redis AI, and GIMP to process our images. We'll also define a whole bunch of constants to make our code more readable. Here we have things like the path to the model, the labels for decoding the output, more on that later, and the keys we'll use. To use our model, we need some basic information. We parse the list of images we want to classify from the command line arguments, load the labels for decoding the results from the file system, and use these to define the shapes for the input and output tensors. Oh, and we can't forget to connect to Redis. With all that out of the way, let's load the model from the file system using Node's built-in IO libraries. We'll store its raw bytes in a variable called blob. Now we can call ai.modelSet to load the model. This is a TensorFlow model that runs on the CPU, so we'll specify those options. TensorFlow also requires us to provide the names of the input and output nodes for the model. This is a TensorFlow thing that models for other backends don't require, but they're easy enough to specify. Lastly, you want to provide the actual bytes that make up the model. We're going to do this as a blob, which we've already loaded, so just pass it on in. To actually use the model we've just uploaded, we need to provide an input tensor. MobileNet expects a tensor of one or more images of a specific shape, which we defined in code earlier, and with specific values of a specific type and in a specific range. Each image must be 224 pixels wide and 224 pixels tall. No more, no less. Furthermore, each color channel, red, green, and blue, needs to be represented as a separate layer. So the image can be represented as an array that is 224 wide by 224 tall by 3 deep, one each for red, green, and blue. These dimensions define the shape of the tensor. So a tensor representing an image would have a shape of 224 by 224 by 3. However, I said MobileNet wants a tensor of images, not just a single image. That means we need to add another dimension with a size equal to the number of images we want to input. This gives us a 4-dimensional tensor, and probably a headache as we try to visualize it. MobileNet expects the images to be the first dimension of the tensor, so we need to add that number to the beginning of the tensor's shape. Let's do 2 images, an axolotl and a zucchini, giving us a final shape of 2 by 224 by 224 by 3. But wait, MobileNet also expects the tensors it receives to consist of 32-bit floats with values from -1.0 to +1.0. Each value represents the intensity of a particular color, red, green, or blue, for a particular pixel and for a particular image. -1.0 would be none of that color, so no red, for example. And +1.0 would be all of that color, all red. Unfortunately, our zucchinis and axolotls aren't in this format already. The size is wrong, we have an alpha channel in addition to the RGBs, and all the images are separate files in formats like PNG or JPEG. So, we have to write some code to convert these images to a format that IO Redis can understand and pass along to Redis AI. Let's solve this by mapping our array of image paths, retrieved from the command line earlier, to an array of node buffers. For each path, we will use the GIMP library to load, resize, and convert our file into an array of bytes. GIMP does a lot of the heavy lifting here for us. The bytes we get back for each image are in the pattern of red, green, blue, and alpha. We only want the red, green, and blue. We don't care about the alpha, so we need to skip every 4th byte. And each byte, well, is a byte. But MobileNet expects a value between -1.0 and +1.0. So we need to convert these bytes to floats with values that fall into that range. To do this, we'll divide each byte by 127.5 and subtract 1, instant float. Once we have our 3-dimensional array of floats, we can convert it to a buffer, which is what IO Redis prefers, and return it. We do this for the axolotl and the zucchini, and end up with an array containing 2 buffers. We need to merge our buffers into a single buffer before creating our tensor. This is done simply by concatenating them. Before we can perform any inferences with our model, we need to store our tensor in Redis. To do that, we'll use the ai.tensorSet command. We specify the key for the tensor and the type, float, since that's what MobileNet wants. We use the spread operator to insert the shape of the input tensor, 2 by 224 by 224 by 3, if you recall, and we pass in our image data as a blob. Now, we just need to run the model to get our inferences. We use the ai.modelRun command, specifying the key the model is stored in, MobileNet. The keys for our input tensors, we just have the one we just created, and the keys for an output tensor, which Redis AI will create, and again, we only have one of. So now we have a tensor with our inferences in it. Time to decode it into something for us humans to read. How do we do that? Well, first we need to understand what's in the tensor. Then we can decode it. The output tensor for our example has a shape of 2 by 1001. The first dimension of this tensor is for the number of images we want to classify. So we got 2, one for the axolotl, one for the zucchini. If we had more images, this dimension would be wider, but what's the 1001 for? Well, MobileNet can classify 1001 things, so we need a score for each thing it can classify. All 1001 of them. Each position in the tensor represents a particular thing. Position 30 is our friend the axolotl. Position 940 is delicious zucchini. The score in the position represents how confident the model is that the picture, in fact, is a picture that contains that thing. All the values for a particular image add up to 1.0. This allows us to think of these numbers as percentages. So the model might be 85.3% confident that the image is of an axolotl, while only 0.1% confident that it is an image of a common newt. Let's get the tensor into our code. We can use the ai.tensorGet command to do this. Follow it with the tensor key, and then tell Redis AI we want this as a blob, and IO_Redis will return a buffer. Note that we're using the .callBuffer function in IO_Redis, where we have been using the .call function. This is because we want that buffer back. Once we have that buffer, this gnarly bit of code loops over it, reading out all the floats and making it a two-dimensional array with the same shape as the tensor. Now that we have this array, we can figure out what is in each image. Just select the largest value in each row. The column it is in tells us what the image contains. For the first row, the largest value is, let's say, 0.853, and is in position 30. Position 30 is for the axolotl, so the model is 85.3% confident that this is an axolotl. To turn the results into something more meaningful for humans, we need to decode the results. This is just a matter of loading the labels, which we did back at the beginning, into a parallel array of strings that maps to the 1001 items the MobileNet can classify. We merge these arrays together with a map. Then we sort and slice to get the top results. We're going to take the top 5 results, as it can be useful to see what the runners-up might be, especially for images that the model might be having trouble with. Putting it all together, we end up with about 100 lines of code that quickly classifies all the images you want. Let's try it out. We enter the command and presto, results. The model is 85.3% sure that that's an axolotl and 96.6% sure that the other thing is a zucchini. And the second place guesses are pretty good too. 0.5% for a banded gecko and 0.8% for a cucumber. Although fifth place being a toilet seat for the axolotl is a bit weird. So, we built a thing. In doing so, we've seen how to use Redis AI from an application to add models, set and get tensors, and perform inferences. Along the way, we got into the nitty-gritty bits of encoding images into tensors and decoding the results of a model run. Pretty neat stuff. If you want to play around with the code yourself, it's all out on GitHub. The link is in the description below. And once you start tinkering with it, you'll want to check out redisai.io. It has all the documentation you'll need to explore and expand on this sample code. Thanks for hanging out and learning about Redis AI. We'll be making more videos on it and other Redis modules. Make sure you don't miss them. Smash that subscribe button and ring that bell to get notifications when we publish new stuff. And give us a like, but only if you really liked it. Thanks.